we're going to go and continue to talk about how to solve differential equations using, in this case, slope fields. Slope fields. So, without further ado, let's look at this one. So, I have a slope field. Now, what is a slope field? A slope field is essentially a differential equation where we're solving it graphically. And so, how do you solve it graphically? Well, you have a graph with a bunch of dots. And given this differential equation, a differential equation is essentially, this right here is a slope of tangent lines. All right, and what we're going to do is we're going to plot in a bunch of different tangent lines on this graph right here. Okay, and so to do that, we're going to start by picking some points. So, for example, I'm going to pick a point right here. All right, 0, 0. Now, when I put in point 0, 0, and this is what I'm going to usually do, I'm going to have x, y, and I'm going to have over here what my derivative will be. I'll say this is dy dx. Okay? Now, when I plug in point 0, 0, and that's what you essentially do, just take a bunch of points and plug them in there. Okay? What do we get for our slope of this tangent line? Because that's what you need. A point of slope, so I have a point, and now what's my slope? Well, I plug in 0. Notice that the x is the only thing that here. So if I plug in 0 in for x, I get 0 in for my slope. So that's going to be a horizontal line right there. Now, you might notice something, that because this differential equation only has x, all the values that have x as zeros will always have a slope of 0. So it really doesn't matter what the y values are. So, like, for example, this one where x is 0, we get a 0, 1. All right, slope is going to be 0. All right, we have 0, 2, and you can see the slope is going to be 0. All right, and all these values, no matter what you put in, even if I put in a -1 or a -2, it's always going to be 0, and that's what we have. So we'll have an infinite amount of possible solutions to the differential equation because it changes depending on what ever c is. Okay, so for this particular differential equation, the key thing I have to know is what is my value for x. So if I put in a 1 in here, I'm going to have 2 times 1, which gives me 2. So right here, I'm going to have a slope of 2. And I'm going to kind of guesstimate what my slope of 2 is. And all of these will be a slope of 2. I'm just going to put m equaling 2 here. This is m equaling 0 there. All right. So they're all going to be parallel to each other. And there we have right there. Okay. Now, if I put it in a -1, I'll have 2 times -1, which gives me -2. And so I have a slope of -2. All right, so I'm going to have all these going to be -2 right there. And I have a slope of -2. All right, -2. And I can go over here and put in like a 2. And if I have 2 times 2 is 4. All right, and when I do that, it's going to be a little steeper. So then we have a little slope, which is going to be 4. And so I have that. All right, and they're all positive. And over on this side, when I plug in my -2, it's going to be -4. And you can see that's going to be steeper right here. And we can go, oops, yellow. Make sure you draw it like kind of accurate. All right, right there, 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 there. Yeah. Okay. Now, from here, let's say I want to solve this differential equation with the initial condition of 0, 1. So that's my point, 0, 1. So I'm going to go 0, 1. 0, 1 is located right there. Now, how does this happen? Well, the slope that is 0, the graph is going to have a horizontal tangent line or a max or min here, right? So, and then we have to follow the slope. So we see the slope right here, it increases and it gets bigger and bigger and bigger, like so. And you can see that kind of goes like that, bigger and bigger, like so. And what does that look like? Well, it looks like a parabola. Parabola, which is very, very interesting. So this graph is going to be a parabola. Well, how can we verify this? Well, we can actually solve this differential equation. Okay, we can actually solve this differential equation. So I took this, and let's say I had dy dx equals 2x. And I want to solve this differential equation. Well, I would separate variables. So I could say I have dy. So if you watch the other video, I'm going to have equals 2x dx. I'm then going to integrate both sides. So I'm going to integrate. The integral of dy, because there's still 1 there, is going to be just y. This side is going to be 2x squared divided by 2, and then we have our plus c. Well, right here, all right, I have y equals x squared plus c. Well, I'm putting in now my 0, 1. So if I plug in 0, 1, I'm going to have 1 equals 0 squared plus c. C is going to equal 1. And so I have for my final answer, y equals x squared plus 1. That's the solution for this particular differential equation. And you can see that matches actually the graph in the yellow up there, right there. And so the solving the differential equation, when you do a slope field, is basically a graphical representation of what the solutions, all right, of this differential equation would be. To find a particular solution, you need what's known as initial condition, which is a point, all right, that you plug in to solve for C, which gives you then your one solution. Well, let's try one more. Let's say I have a problem like this, okay? I have a problem like this. I want to solve this. Now, very similar, all right, to the past one. So we have 1 over x plus 3, 1 over x plus 3, okay? And so if we solve this one, okay, we can go over here and we're going to solve this differential equation. We'll use the slope field with x, y, and we'll have our, all right, dy dx here. Once again, you see there's only x values. So whatever I plug in for x will give me my answer. So I usually start with 0. So if I plug in 0 here, I'll have a value of 1/3. All right. And so if I go over here, I have 0. I have a slope of 1/3. So rise 1, run of 3. 1 does 3. And so it's probably going to be looking like that. Okay. If I have and then all of these are going to be looking at that same thing. So I'm just going to make them all kind of 1/3. All parallel to each other. And then I'm going to put in a 1. When I put in a 1 in here, I'll have 1/4. All right, 1/4. All right. And so I'm going to have 1. It's going to be a little bit less steep. So I have right here a little flatter. And if I put in a 2, I'll have 1/5, even flatter still. All right. You can see that there is almost like it's like coming like super flat. Okay, we have something like that. Now, what happens when we go to the other side? Let's play with -1. -1 is going to be 1/2. 1/2. And so if you look at right here, well, it's going to be less flat, so a little bit higher. So rise 1/2. So it's going to be like that, a little bit less flat than previous ones. And then we have -2, so that's just be 1. All right. So that's going to be right here. Okay. And then if we put a -3, we notice that we have 1/0. Well, what's 1/0? That's like a vertical. That's undefined. And so we have a straight vertical line going like this because that appears to be a vertical asymptote of some sort. All right. And so let's say I want to draw the solution curve at 0, 1 again. 0, 1 again. So 0, 1 is located right here. Well, if I follow this, it's going to come right here, but then we know it appears to be flattening out, getting less steep. Then it gets a little bit more steep. It appears to be going like that. Well, what type of graph is that? Well, that looks like a logarithm, if I say that. So let's just verify what this answer would be. Let's solve this differential equation just to verify what the slope field that we found actually is. So if we have right here, we'll separate our variables again. dy equals 1 over x plus 3 dx. There's a y over here. So we're going to integrate both sides. We have y equals, all right, what is this going to be? Well, 1 over x plus 3 is natural log of x plus 3. All right, x plus 3, all right, plus c. We'll put in our c value, we have 0, 1, so I'll put in 0, 1. All right, so I have 1 right here, and then we have natural log of 0 plus 3 plus c. What is that going to be? All right, and so finally, what is our c value going to equal? It appears it's going to equal 1 minus the natural log of 3 equals c. And so we have our final answer, y equals the natural log of x plus 3. So our vertical asymptote is at the -3. All right, plus the quantity 1 minus natural log of 3. all right, appears to be that one value that we have, all right, and that's our solution curve. Pretty crazy, right? All right, but also pretty awesome. So that is our slope fields, okay, and we're going to keep on working on some more of those. So hope this helps you out, and yeah, good luck and God bless on the rest of your problems.